So the first topic of today's discussion is sampling process. Sampling is a very important aspect in the research as well as in our daily life. Most of us are aware that sampling is the common method used into our daily life. For example, cooking of the rice. A housewife examine only 2 or 3 grain of the boiling rice to know that whether the pot is ready or not. Another example of sampling from our daily life is when the farmer is checking the quality of the wheat. He just take out a handful of the grains and ascertain the quality of the entire lot of the wheat. This is again an example of an sampling process that is used into our daily life. Another most important example is blood examination conducted by the doctor. The doctor do not exclude all the blood from the body. He take only few drops of the blood to know the condition of the body, and examination of the blood is based again on an sampling process. Or another example is when a businessman places order by examining only a small sample of the same. These are some of the examples of our sampling process that is used into our daily life. Into our day-to-day practice, for example, we are being in faculty. We also use a sampling process into our classroom. For example, if I'm dealing with some of the complex topic into my classroom situation and I want to investigate that whether my class students are able to understand the whole concept or not. If into my class there are 60 or 70 students are sitting into the classroom, what I'm going to do to check the quality of the instruction, I'll pause question to 1 or 2 students, and from that representative sample I come to know that whether my class is able to understand the whole topic or not. This is again an example of an sampling process. This is a common example that we are using into our day-to-day life. But in research, sampling is a very systematic and scientific process to be conducted by the researcher. And if why we need sampling? Next question arises, why we need sampling? Why the researcher is not able to investigate whole of the population? Any participant would like to answer?
Sometimes population is disruptive because we will be taking each and every unit in the population. It is not possible. Like if we have to check the burning strength of candles, we can't burn each and every candle.
Each and every candle.
And sometimes it is infinite. We can't count.
Expensive and time consuming.
It's expensive and time consuming. From any connected center, any participant would like to answer why we need sampling in research process?
Ma'am, this is because of the, as once somebody told, it's a time constraint. Yeah, and we cannot able to reach each and everyone, and a few things will always gives you a better results.
Okay. So as rightly added by all the participants that if the problem is studied as a whole, we require lots of time, lots of resources, and sometimes the population is infinite. We are not able to count each and every unit of that particular population. Means if the researcher is want to study the population as a whole, he required 3 M's. When I said 3M, 3M means manpower, material, and money. On the other side, so if we are going to study population as a whole, there are chances that the observation is not reliable that is taken by the researchers. So we need sampling into need a systematic and scientific sampling in various research process. So next is, what do you mean by an sample process? As given into the PPT, a sampling is a smaller but hopefully representative collection of the unit from a population used to determine the truth about that particular population. Means on the basis of the sampling process, we are able to generalize or we are able to predict the behavior of the mass phenomena. Means from a larger population we take out some of the unit, but yes, those unit must be representative of that particular population, and we are able to predict and generalize the behavior of that particular population. And this is possible because no statistical population whose element would vary without any limit. And for example, if I'm taking an examples of apples, apples are taken from same tree. They may be vary into size, they may vary into the color, they may vary into the taste, but all are considered as apples. These are the identical unit, and from that particular population we take out some of the unit and check the quality of that particular phenomena. So sample is an representative unit that is taken out from the whole of the population to know the quality or to predict the behavior of the population as a whole. And the process means when we are selecting small number of an element or unit from that particular population is considered as sampling process, and we expect that the units we are extracted from that whole population will be representative of that particular whole population. And while choosing the sampling process, we need to ask two different questions. First question is, in the definition of sample, we consider that it's a smaller or collection of the unit from a population. The first question need to be asked to yourself being a researcher is how much we need. Means what will be the sample size to get the information of that particular whole population. Another important thing to consider while choosing the sampling process or sampling technique is where the unit that we are extracted from the whole population, are those unit able to predict the behavior of the population? These are the three important issues that are considered when we are choosing sampling process. In nutshell, sample is a smaller or representative unit of the whole population, and the method of selecting relatively smaller number of the unit is considered as sampling process. Sampling is used in our everyday practices also, but in research it's a systematic and scientific process to conduct sampling for various research problems. Before going to the details of different type of sampling method, another important terms need to understand for the sampling processes. First one is the population. In statistical terms, the data under investigation is considered as population, and sometimes it is also considered as universe as a whole. When I said population and when I said number of units can be different elements, that can be individuals, that can be families, that can be groups, that can be any object that is the part of that particular research problem, and it is considered as population. And important term that is related with the population is a parameter. When I said parameter, parameter means any constant that is derived from an population is considered as parameter. And for sample process, parameter is considered as statistic. Statistic means if the constant is derived from the sample, it is considered as statistic, and if any constant derived from the population, it is considered as parameter. Here I would like to take an example of, for example, in a class of 100 students, for example, being a faculty, you have a class strength of 100 students, and you want to analyze the average percentage marks of the student. And I want to calculate the population parameter. Population parameter will be, population is of 100 students. For example, I selected sample of 10 students. My sample size is 10, population size is 100, and population parameter is percentage marks of all the students divided by the total number of the students. It is considered as population parameter. And being a researcher, if I want to calculate the sample parameter means from that particular sample, means that percentage total percentage marks of that particular 10 students divided by the sample size. The constant derived from this is considered as statistic. This is the basic difference between population parameter and statistic or sample parameter. So sample statistic is an estimation of an population parameter. It does not provide us a true or exact value of the population parameter, but it's an estimation of an population. And Another important term is defined target population. Target population means the group of the interest of the researcher and the characteristics to which the finding of the study will be journalized is considered as target population. Means from that particular 100 student who will be the representative of that particular class, that representative group is considered as target population. When I said that sample statistic is the estimation of an population parameter, here I would like to take another example is, for example, I want to analyze how many students who are sitting into my classrooms are wearing specs. And my population size is 100 students, and for example 20 students are there who are wearing specs into my classroom. The population parameter will be 20 divided by 100, that is 1 by 5. And sample statistic is, for example, I take out 10 different students as a sample of my classroom environment, because being a researcher I don't want to give time sample to that whole population. I select 10 different students, and out of then that 10 different student, only 3 students are wearing specs. My sample statistic will be 3 divided by 10. 3 divided by 10 is not similar to 1 by 5, means I am getting only an estimated value of that particular population. So with the help of sample statistic, we have a estimated value of that particular population. This is the basic difference between parameter and statistic. Next is sampling frame. Concrete listing of all the elements is considered as sampling frame, and sampling error arises on account of the sampling. Sampling design is a subset of the cases from the population chosen to represent it. So in simple terms, sampling process is a plan to obtain sample from a given population. The breakup of the sampling methodology processes, first one is, who do you want to generalize to? Obviously, it's a universe or an population for which I want to estimate some kind of an result. What population can you get access to? The study population. How can you get access to them? Then I will need a sampling frame. And who is in your study? The unit from that particular population who are representative of that whole population. These are the definition of sample, sampling process, and different terms that are used into sampling process. Then what are the various theoretical bases of an sampling process? Theoretical basis of an sampling process means, how do I select a sample? What will be my sample size? What will be my different sample techniques? These are all considered as the concepts of an sampling or theoretical basis of an sampling, and there are 4 different laws related to it. First one is law of statistical regularity. Law of statistical regularity present that the sample is selected at random and the sample is of larger size. Here I would like to take an example as, if a researcher intend to make a study of the average height of Punjab University student. For a researcher, it is not necessary to calculate the height of each and every student that is associated with Punjab University, Chandigarh. What the researcher will do? The researcher will randomly select few number of students from that whole population and measure their height, and then calculate the average height of the student associated with Punjab University, Chandigarh. This is considered as law of statistical regularity. Means if the sample is taken at random from a population, it is likely to possess the same characteristics of that particular population. This is the first concept of sampling process. Second is law of inertia of large number. As the name of present, large number means larger the size of the sample, more accurate will be the results derived from that particular sampling technique. This is considered as law of inertia of large number. For example, being a researcher, I want to study how many times I will get 5 heads and 5 tails when I tossed a coin. And being a researcher, if I selected to toss that particular coin 10 times, there are minimum chances that I will get 5 heads and 5 tails. But for the same case, if I increases the number of the chances of tossing that particular coin, for example, if a researcher toss the coin 1000 times, there is a probability that the equal number of heads and equal number of tails will be increased in that particular case. Means the researcher increases the size of an sample, and from that particular larger size of an sample, there are chances that we get an accurate result and proper characteristics of the population under study. This is considered as law of inertia of larger numbers. Next is law of optimization. Law of optimization means using minimum effort, we are able to get the maximum information from that particular population. I said maximum information. I don't say that the total information of that particular population. Means estimation of the population can be get by using minimum effort by the researcher if he is able to select a representative sample from that particular population. And law of reliability and law of validity. Statistic give us a valid information about the population if we're using random or probability sampling techniques. These are some of the bases of an sampling process. Next is, what are the essentials of an sampling process? Essentials of an sampling process means, first one is a sample must be a representative of that particular population or representative of that particular universe. Otherwise, the results obtained may be misleading. Next is adequacy. Adequacy means the sample must be adequate, otherwise it will not represent the characteristics of that particular population. Independence. All the items should be selected independently. Means if I selected one item at a time, there is no effect on the another items that I'm going to choose afterward that particular item. Every item has the same chances of being selected into my sample. This is considered as independent selection of sample. Next is homogeneity. Homogeneity means no basic difference in the nature of the unit in the universe of that particular sample. For example, if I'm going to take two different samples from that particular population, being a researcher, my responsibility is to hold the homogeneity between different samples that are taken out from that particular population or from particular universe. Next is how we select the sample size. What is sample size? Sample size means? Yes. Sample size is simply the units that are selected out from that particular population is considered as sample size, and there is no fixed rule for defining an sample size. There are chances that smaller but well selected sample is more useful as compared to the larger but badly selected sample. Another factor that affect the sampling process is an experience of that particular researcher. An experienced researcher will select more representative sample as compared to the inexperienced researcher. And there are cases when if the sample size is small but not selected properly, the inferences drawn for that particular population may be misleading. And the sample, on the other hand, if we selected a larger sample, we will require more number of resources in terms of time, in terms of money, and in terms of manpower. So the size of the sample selected for that particular population must be optimum. When I said optimum, optimum means the sample size that fulfill the requirements of efficiency, that fulfill the requirement of representativeness, and that fulfill the requirement of reliability and flexibility of the population under study. Depending upon our research problem, we are going to select the sample, and there are various parameters which are considered while selecting the sample. First one is the size of the universe. If the size of the universe or the size of the population is large, means the sample selected must be large in size. If the size of the universe is small, the smaller sample can also represent that particular population. The number of the resources available. The number of the resources available means if we are having immense number of resources at hand, we can select a larger sample, but resources are a bigger constraint when we are involving into research process. So depending upon the resources, we are going to select our sample sometime. Next is the degree of accuracy and the precision required. The greater the degree of accuracy is required, it is not necessarily the sample is larger or the sample is smaller. The degree of accuracy is totally dependent upon our research problem or the population that is under study, and depending upon the characteristics of a population, the researcher will decide the size of an sample. Next is nature of the universe. Nature of the universe means if the universe is having similar kind of an characteristics or the population is having similar kind of an characteristics. In simple term, if the universe or the population is homogeneous, then we will need smaller sample for that particular study problem. And if the variation of characteristic is maximum in that particular population, or the population is heterogeneous, in that particular case we need larger sample size. Next is nature of study. Nature of study means, for example, I'm going to study a continuous but an intensive study. Continuous and intensive study, I need a smaller sample so that all the resources are optimally utilized for that particular problem. But in case if I am having non-repeated kind of an study, or I am having extensive kind of an study, for that particular study problem, I need a larger sample that will represent my whole population at once. So depending upon the nature of the study, again, the sample size will vary. Method of the sampling adopted. There are two different sampling technique. First one is probability sampling technique and non-probability sampling technique. And under these classification, there are different types of sampling method. Depending upon which type of a sampling technique I'm using, again, sample size is dependent upon that particular method. Next is nature of the respondent. Nature of the respondent. For example, if it is expected that the number of the respondent will not answer to my questionnaire or do not respond to my survey, in that particular case, I need a larger sample so that I can represent my population as a whole. So these are some of the parameters need to be considered when we are selecting the size of an sample for the population under study. What are the different sampling method? First one is probability sampling method and non-probability sampling method. Under probability sampling method technique, we are going to study simple random sampling, systematic random sampling, stratified random sampling, cluster or area sampling method. And under non-probability method, convenience sampling, judgment sampling, quota sampling, and snowball sampling. Now, what is probability sampling? Probability sampling is an random sampling technique in which every unit of the population has a equal chances. When I said equal chances, means the chances are greater than 0 of being selected in that particular sample size, and the probability can be accurately determined. When I said random sampling technique is the method of the sampling which provide every element in the population an equal and known chances of being selected in this particular method. Random doesn't mean that I am randomly selected the sampling unit from that particular population. Means it's not a haphazard or a hit miss kind of a technique. Means that the selection process is such that the chance will determine what item or which item shall be included into the sample. Means selection of the sample is totally dependent upon the chance. It doesn't depend upon the personal biases taken by the researcher. This is considered as simple random technique. In a simple random technique, for example, my population is capital N and my sample population is small n. And independence, and in simple random technique, we said that there is a chance which define the selection of an item, not the biases taken by the researcher. Independence of selection means selection of a particular item in one draw has no influence on the probability of selection in any other draw. And simple random sampling technique is conducted by using random tables. In this particular table, suppose that you are going to select 30 students at random from a population of 900 students. Means my population size is 900 and I'm going to select 30 students out of that particular population. So my sample size will be 30. How we use this particular random table is, for example, each of the student in the population is given a code from 0001 to 900. 0001 to, why 0001 to 900? My population size is of 3 digits. I'm going to label this random table as 3 digits started from 0001 to 900. If the size of the population is up to 2 units, for example, if the size of the population is of 90 students, then I'm going to label this particular population as particular population started from 01 to 90. How we use this particular random table? You enter a table of random number at any predetermined spot and simply read all the 3-digit numbers. For example, if I'm going to pick the column 10 to 14, in the first row of this particular table, is this table is visible to you, sir?
Yes, ma'am.
So how we use this particular random table? In the first row of the table, it is considered as column and a cursor, and on the right hand, it's the rows. The first column is, for example, 00 to 04. This is the first column. Second is from 05 to 09, and third is from 10 to 14, and so on. And the rows are labeled as 00, 01, 02, and 03. My population size is of 900 students, means I'm going to label this particular random table as 001 to 900. And suppose I pick the column 10 to 14, and from 10 to 14 column I chosen the row number 15. Now look at this random table, and at column 10 to 14 and row 15, the first 3-digit number is 844. Next number is 448, 806, 428, 836, and so on. So I need to select 30 students from that particular population as an sample of that particular population, and any number that is larger than the size of that particular population is discarded. For example, while selecting the sample, if I got the number 919, 919 is larger than the size of the population, that is 900. So I will exclude that particular number. I will restrict up to 900. This is how we select sample by using random table. And simple example of a random table is, for example, in a lottery method. In simple lottery method, what we do, all the slips either numbered or alphabetically named on that particular paper of the slip, and the condition in the lottery method is there must be an identical size, identical shape, and the quality of the paper and color of the paper will be same for each and every lottery slip. These are fixed and folded and mixed into a container, and blindfoldly we select number of the slips out of that container. This is considered as simple random method of selecting sample from that particular population. I can also select 15 to 90 and any of the row from that particular table. Any point from that particular table you can select, and according to the size of the population you have to select the number of the units. Sir, this number is not completed in this particular PPT. This table is actually very large. This is just for an example how we choose that particular random table. So when we are going to use this simple random method technique, when we suppose you are going to study 200 students for the fourth semester, CSC branch, and you want to check the IQ level of that particular student. Is it able for the faculty to identify or to calculate the IQ level of each and every student? Being a researcher, the faculty will exclude a representative sample from that particular population. When I said simple random technique is used for this particular problem, the characteristics of the population is homogeneous. The IQ level will be same for, means there is no much variation between the IQ level of the boys and girls sitting in that particular fourth semester classes. So I will choose simple random technique to select or to know the estimation characteristics of that particular population. So when the population size is not too large and population characteristics are homogeneous, in that particular case the simple random technique is used. And advantages of the simple random technique is there are no chances of the personal biases. As the size of the sample increases, it presents the population in a better way, and strategies require minimum knowledge of the population to be selected, because I randomly selected my sample out of that particular population. But the problem with this particular sampling technique is I need to label each and every population into the list of that particular population, and there are chances that there is a difficulty in reaching all the selected sample. Means if the population is scattered geographically or the variation of the population and the sample is scattered at a larger place, in that particular case the simple random technique is not an efficient method to be used by the researcher. Next is stratified random sampling. In this method the population is divided and subdivided with homogeneous or similar kind of an characteristics. Means it's an attempt to design a more efficient sample as compared to the simple random method technique. For example, for the fourth semester student, in simple random case we will take in the case of IQ level of the student. IQ level is not much varying for boys and girl student, and for the same particular population size, that is of 200 student of the fourth semester, if I want to check or measure the average height of the student, is it possible for me to calculate the average height of the student by using simple random technique? No. In that particular case, I need to divide my class into two different sections. The class of 200 student is divided into two different groups, that is boys and girls. And according to that particular group, the height will be measured, because the height will vary for these different, for boys and girls, whereas IQ level is not much vary depending upon the gender. So for this particular case, I will choose stratified random sampling technique. Means the population size is large and the characteristics under study is heterogeneous. In that particular case, stratified random sampling technique is used. Another example of stratified random technique is, for example, if I need to study, the researcher need to study the consumption pattern of an Chandigarh city. For study the consumption pattern of an Chandigarh city, or before deciding the stratification, we must know the certain traits of that particular population. What kind of communities are residing into the Chandigarh city, vegetarian, non-vegetarian, depending upon their lifestyle, we need to divide the whole population into different stratas, and on the basis of those strata, we come to know the characteristics of that particular population. How to select stratified random sample? First one is, what is the base of my stratification? Base of the stratification means what characteristics should be used to divide the population into different stratas. And when we are going to construct a strata for that particular population, First thing is the strata that formed from that particular population must be homogeneous in nature. Within the strata, there must be a homogeneity and different kind of strata. For example, if I divided my population into three different stratas, there is a mixed marked differences against those particular strata. Strata 1 will having different kind of characteristics as compared to strata 2 and strata 3. Means within the strata there is a homogeneity and between the strata there is a heterogeneity or marked differences. Next is number of the strata. How many number of the strata must be feasible for the problem under study? According to the literature, more than 6 stratas may be undesirable for any kind of an research study. Sample size within the strata. Sample size within the strata means how many observations should be taken from each strata. That can be equal allocation or proportionate allocation. When I said equal allocation means when there is a not much variation among the population. In that particular case, disproportionate allocation or equal allocation is to be used. For example, if I divided my population into three different strata, in disproportional allocation, 1/3 of the sample should be taken from each of the strata. And when I said proportional allocation means, for example, there are 15,000 technical students, and out of that 15,000 technical student, 3,000 are mechanical engineers, 2,000 are biotech engineers, and 10,000 students are from CSC and IT. And I want to take a sample size of 500 students. My population size is 300 plus 200 plus 10,000 student means total population size is of 15,000 student, and I want to exclude a sample size of 500 student. So the number of the students selected from each strata will be, first case is mechanical engineering student that are 3,000. 3,000 student divided by the total population multiplied by the required sample size. 3,000 divided by 15,000 multiplied by the required sample size by the researcher. By this we come to know the proportion of the mechanical engineering student. Likewise, in the cases of biotechnology, that are 2,000 student, 2,000 divided by the population size 15,000 multiplied by the required sample size, that is 500. Accordingly, the proportion from each strata is to be taken out. Next is, what are the various advantages of stratified random sampling technique? Stratified random sampling technique is a more precise sample, means it balances the uncertainty that is created by the simple random technique against the biases of deliberate selection of any number from a random table. Can be used for both proportion and stratification sampling, means accuracy is maximum if the strata formed is uniform or homogeneous within the strata, and between the strata there is a marked differences among themselves, and sample represent the desired strata, and it also reduces the time and expenses of the researcher. And different disadvantages are, utmost care is to be taken when we are dividing the population into different strata, otherwise the results may be misleading. Another important parameter is when the sample is distributed widely or when the sample is distributed geographically, then the simple random cost for observation may be quite high. These are some of the advantages and disadvantages of stratified random sampling technique. Next is systematic random sampling. Systematic random sampling is also known as quasi-random sampling technique. In systematic random sampling technique, The sample is formed by selecting the first unit at random and select additional unit at evenly spaced interval until the sample is being formed. Means the researcher is selecting every kate until the intended sample size is obtained. And how we calculate the internal, that is population size divided by the size of the population, and formula is capital N divided by N. Where this method is being used, the systematic random sampling method is used when the complete list of the population is already available from which we can draw an sample, or while using this systematic random sampling technique, the list can be prepared numerically or it can be arranged alphabetically to have a flow to select every kth unit from that particular population. The step to be followed: select a random number which will be known as k, and get a list of the people or observe a flow of the people and select every kth person. And when we are calculating the kth interval, there are cases that we get a fractional unit. First case is if the fractional value is less than 0.5. For example, the number of the student is 1020 and I want to take a sample of 200 students. My kth interval will be the size of the population divided by the sample size. If the size of the population is 1020 divided by 200, the kth interval will be 5.1. The first rule while selecting this is if the fractional value is less than 0.5, then it is omitted. The kth interval will be the fifth number selected by the researcher. Second case is if the fractional value is more than 0.5. Number of the student is 1150 and sample of 200. Means my population size is 1150 divided by sample size, that is 200. The kth interval will be 5.75. 5.75 in this case, my kth interval will be sixth number. And third is if the fractional value is exactly 5. In that particular case also we will increase a number. For example, if the population size is 1100 and sample size is 200, population size 1100 divided by 200, it will become 5.5. Then my kth interval will be 6. This is how we select the kth interval for the given population. Next is some of the advantages are sample selection is simple and convenient, and time and labor is involved very less. And all member of the population do not have an equal chance of being selected because I need to select every kth interval given in the list of population. An example of a systematic random sampling technique is, for example, in a class of 40 students, I need to know the achievement score of my class student, or I need to calculate the average marks of my class student. For example, my class strength is up to 90 students and I need to calculate the average marks obtained in any particular subject, for fluid mechanics. If I'm using systematic random sampling technique, why I'm using this particular technique? Because the list is already available to me and I can systematically select some of the students from my class to know the achievement score for that particular overall picture for that particular achievement score in the subject of fluid mechanics. By using systematic random sampling technique, I can identify the achievement and I can identify the effectiveness of my instructional strategy into my classroom environment. Next is the cluster sampling. Cluster sampling is also known as area sampling when the list of individuals are unavailable or when the characteristics of the population are unknown. Means when the characteristics of the population is not well known, or when the list of the individual are unavailable. In that particular case, we uses cluster sampling technique. For example, if the researcher want to
Madam,
take
I
a
have a question.
sample. Yes, sir. You're from which institution, sir?
Madam, we are from RV College of Engineering, Bangalore.
Yes, sir.
All of the examples you gave so far
Mm-hmm.
have countable samples. For example, 200 students of computer science.
Mm-hmm.
So the count is 200. But I have a different case where I need to take 10 ml of liquid
Mm-hmm.
from a container having 1 liter of liquid. So in such a case, can we use this random sampling technique?
Sir, from 10 ml, you want to take a sample of 10 ml from 1
Yeah,
liter of.
1 liter.
No, sir, for this particular case, you cannot use simple random technique.
Yeah,
It's in a different
any
case
of
of
the random
experimental
sampling
study.
techniques for that.
Mhm. In the
Okay, madam.
initiation of my lecture, when I'm giving the example of blood examination taken by the doctor. When the doctor is conducting a blood examination, he is not taking whole of the blood from our body. He'll just take few drops of the blood to know the constitution of the body as a whole, or the problem or the disease of that particular person. So depending upon sample to sample, we need to classify the technique of sampling.
Okay, madam. Thank you.
Okay, sir. Cluster sampling technique is when the characteristics of the population are not well known, or when the list is not available to the researcher. In that particular case, the cluster sampling technique or area sampling technique is to be used. Suppose if the researcher want to take a sample of 20,000 students of technical university. For this particular case, if the researcher is going to study the whole population, he will require large number of resources. For this particular case, the researcher will first uh, classify the sample into different number of stages. For example, he selected few colleges and listed all the colleges, and from that particular list he selected few number of colleges. This is the first stage of that particular case. Then for those colleges, he selected few departments, and from those particular department, he selected few number of students who act as a sample for that particular population. So this is an example of an cluster sampling technique, when the researcher is going to divide the population into number of clusters, and from those clusters, he is going to select the sample of that particular population. Some of the advantages of cluster sampling are: cluster sampling is a flexibility in sampling which is lacking in other method. It is provided by the cluster sampling. But the disadvantages of cluster sampling technique is it never represent, it is not 100% representative of that particular population, and it's a less accurate method as compared to the other method. And when this method is going to be used by the researcher, the cluster sampling technique is used when we do not have a defined sampling frame. In that particular case, when we need to conduct an survey. For conducting survey of underdeveloped area, the cluster sampling technique is mostly used. Next is multi-phase sampling. Multi-phase sampling is the purpose changes at each phase. For example, at one, the selection of the sample might be based on the criteria of geography, another on the basis of the economical condition, and on the basis of the political criteria. Depending upon the characteristics of the population, the sample is to be selected by the researcher. Now come to non-probability sampling technique. Non-probability sampling techniques are used when the researcher do not want a representative sample, but to gain insight into a problem. In that particular case, he will go for non-probability sampling technique. In this sampling technique, some of the element of the population have no chance of the selection, and the selection of the, in other words, the selection of the sample is on non-random basis. Example is, We visit every household in a given street and interview the first person to answer the door. When we are using this particular method, it is considered as non-probability sampling method. It is possible that some of the people who open the door are not ready to answer the question of that particular interviewer, and only the housewives who are at home at that time are able to answer that particular question of the researcher. So this case is considered as non-probability sampling, when each and every item that is present into the population have no equal chance of being selected. Different kind of non-probability sampling techniques are: first one is judgmental sampling. Judgmental sampling means the choice of the sample item is depend exclusively on the judgment of an experiment of the investigator or the researcher. For example, if I want to analyze the spending habits of my class student, and based on my judgment, I select 10 students out of 60 students according to my opinion who are the representative of that particular class to analyze the spending habits of the student. So based on my own judgment, I have selected that sample of that particular student from the whole class. It is considered as judgmental sampling. And advantages of judgmental sampling are: when small number of sampling units are available into the universe. In that particular case, depending upon the experience of the researcher, depending upon the opinion of the researcher, he will select a representative sample of that particular population. When we want to study some unknown characteristics of the population, some of whose characteristics are known, means for that particular population, for that particular class for which I'm going to analyze the spending habit of the student, I know the economical status of my class student. That is the known characteristics of that particular population. And depending upon the economical status of my class student, I will select a sample to represent the whole population. To solve this, judgmental type of an sampling is solved for making public policy decisions or in everyday business or in marketing area, based on the experience of the person who are conducting that particular sampling technique. Means when public policy decisions are made by higher authority, the only practical method to arrive at an most urgent solution is by using judgmental sampling technique. And different disadvantages are: it's a not an scientific method, because the population unit to be sampled may be affected by the personal prejudice. For example, if the researcher hold the view that the wages of the worker in certain establishment is low, and by adopting this particular method of judgmental sampling, he only select the worker with the low wages for the sample. That is not actually true. So subjectivity is possible when he is going to select sample with the help of judgmental sampling technique. So it's totally depend upon the reliable experience of the researcher of the judgmental holder. Next is the convenience sampling. Convenience sampling is also known as chunk. When I said chunk, means a chunk is referred to the fraction of the population being investigated, which is selected either by probability or by judgment, neither by probability nor by judgment, but only by the convenience of the researcher. Convenience sampling is involved choosing the nearest individual to serve as a respondent and continuing the process until the required sample size has obtained. For example, I need to conduct a survey on a textile industry, and I am going to choose convenience sampling technique. For a textile industry, I go to nearby textile industry and select sample from that particular industry only, rather than going to different textile industries. This is depending upon the convenience of the researcher when he is going to select an sample. Another example is a sample obtained for readily available lists such as automobile registrations or directories. If the researcher is going to select the sample from those particularly available lists, that is also considered as convenience kind of an sampling. And steps to be followed is find the people who are easily available for that research. Advantages are the process of including whoever happens to be available at that time, called accidental or haphazard sampling, and find some people that are easy to find. The disadvantages of convenience sampling is difficulty in determining how much of the effect result from the cause. Then where we are choosing using this particular convenience sampling technique?
If I don't want to go that place,
When we said sampling in research is a very systematic and a scientific process, then in research, where the researcher is going to use this convenience sampling?
When he doesn't want to use time.
But it's not a systematic approach to conduct research.
Exit polls. In
Exit polls. Convenience in research. Convenience sampling is basically used to conduct pilot studies. For example, you designed an questionnaire, and to check that particular questionnaire, you select a chunk of an population. For that particular chunk of population, and before deciding the questionnaire to be distributed to the large number of the population, the researcher will use convenience sampling to know the validity and reliability of that particular questionnaire. So to conduct various kind of pilot studies, the convenience sampling is to be used. Next is purposive sampling. Purposive sampling means the deliberate selection of the sample unit conforms to some predetermined criteria. In convenience sampling is dependent upon, we totally dependent upon the convenience, how many members are easily available to conduct that particular pilot study. In purposive sampling, the basic difference is the sample unit conforms to some predetermined criteria. Means the purposive sample is selected from the population by some arbitrary method. And when I said arbitrary method, means this method is decided on the basis of the available information thought to be representative of that particular population, or it can be by intuition of that particular researcher. For example, a teacher select arbitrary two different groups of students by ability on the basis of available IQ results and past performance score to identify the difference of instructional effectiveness between the two groups. Means the teacher want to analyze the effectiveness of the instructional strategies used by her into the classroom environment, and for this particular case he select two different bases, that is IQ level of the student and the past performance of the student, and she divided the student into number of the group. Then the teacher will pick out the sample in relation to some criteria, and the criteria of that particular teacher is IQ level of the student and past performance of the student. And on the basis of this particular criteria, he will select two different groups, and on two different group he check the effectiveness of the instructional strategies that are delivered into the classroom environment. So this is considered as purposive sampling. Its advantages are purposive sampling is less costly and less time consuming. It ensures proper representation of the population when the investigation has full knowledge of the components of the population and is free from the biases. It ensures proper representation of the population. It prevents unnecessary or irrelevant items entering into the sample per chance. It ensures intensive study of selected item, and it gives better result if the investigator is unbiased and has the capacity to keen observation and sound judgment. Disadvantages are there is enough scope for bias and prejudice of the investigate to play and influence the selection, because the criteria is fixed by the researcher on the basis of which he is going to select the sample. So depending upon the choice of the researcher, there are chances of biases to select that particular sample. There is no equal chance for all the items of the universe to being included into the sample like simple random technique. There is no possibility of having an idea about the degree of accuracy achieved in the investigation conducted by this method, because it totally dependent upon the experience of the researcher, and this method is used unsuitable for the large sample. So the basic difference between convenience and purposive sampling is convenience sampling is totally dependent upon the convenience of the researcher, and that particular sampling technique in research is used to conduct various kind of pilot study, whereas purposive study is used when there is a prefixed criteria that is defined by the researcher, and on the basis of that prefixed criteria he is going to select an sample for that particular research study. Next is snowball sampling. Snowball sampling is usually done when there is a small size of an population, and in this type of the sampling the researcher is asked the initial subject to identify another potential subject who also meet the criteria of the research. The downside of the using a snowball sampling is hardly representative of an population. So in snowball sampling also the researcher will ask the initial subject to identify more number of the subject to be included as a sample. Steps to be followed: find a few people that are relevant to your topic and ask them to refer you more of them. Advantages are: allow the researcher to read population that are difficult to sample when using other sampling method. This process is cheap, simple and cost efficient, and this kind of sampling technique is require very little planning and fewer workforce as compared to the other sampling techniques. Potential for inaccuracy in researcher criteria and resulting sample selection is the disadvantage of the snowball sampling. Next comes to quota sampling. Quota sampling is the frequently used method in marketing research. Quotas are set according to the some specified criteria. Now, what is the difference between the stratified and quota sampling? When we said quota sampling and quotas are set according to the some specified criteria, those criteria can be, yes sir. Is there any question from any center?
Hello.
Yes sir.
Now I'm calling from MIT Meerut.
Yes sir.
Now, what is the formula for sample size determination for finite population and for infinite population?
Sir, these formulas are given in the book of research methodology by Garrett, or you can refer the book by S.P. Gupta on statistical research. In this particular session, I'm not going for the numerical formulas for that particular sampling process. You can refer these two books for knowing the numerical details of the sampling process. Am I clear, sir?
Yes, ma'am.
So, quota sampling is, what is the basic difference between the quota sampling and the stratified sampling? In stratified sampling, the population is divided into different stratas, and in quota sampling also the population is divided into different set of quotas depending upon the specified characteristics of an population. It can be several income group. The population is divided on the basis of the age group, or it can be divided on the basis of their religious groups. So the basic difference between quota and stratified sampling is, in stratified sampling there is a random selection when the population is divided into different stratas, and stratas having a marked differences among themselves, and from that particular strata we randomly select different units for that particular population, either proportionate or disproportionate. But in quota sampling, depending upon the convenience of the researcher, the number of sampling units are derived from that particular quota. This is the basic difference between quota and stratified sampling. The basic Objective of the quota sampling is to control the biases arising out of the known probability method by stratification and setting the quota for each stream. For example, in a radio listening survey, the interviewer may be told to interview 500 people. Those are living into different areas. And out of every 100 person introduced. For example, if in that particular, in 100 person interviewed, there are 60 housewives, 25 farmers, and 15 children under the age of 15. Within this, the interviewer is free to select the people for those he is going to conduct an interview. This is considered as quota sampling method. But in this case, the cost per person interview may be relatively small for quota sampling, but there are numerous opportunity that biases may be involved that may invalidate the result. For example, in the given sample, if there are 60 housewives, 25 farmers, and 15 children, it is possible that the researcher exclude the farmer who are at that time working into the field, and the housewives exclude those housewives who are not present at that time. So there are cost per person interviewed may be relatively small, but biases arised from that particular sampling process is increased. Steps to be followed in quota sampling method is determine what population look like in terms of specific quality, means depending upon the some specified characteristics of the population is divided into different quotas. Create quotas based on those quality and select people from each quota. The process whereby researcher gather data from individual processing identified. And the various advantages of quota sampling method is preventing the decision to be polluted by unnecessary input. Quick and easy way of sampling. It cost per person interviewed is very less, so it will save money and time of the researcher. Different disadvantages are people who are accessible, more difficult to contact, more reluctant to participants are under representation. So these are the probability and non-probability. First, we define the sample, that is the representative unit that is taken out from that population, and sampling is the process involving in selecting the smaller number of the unit from that population. The constant derived from a population is considered as parameter, and the constant derived from the sample is considered as statistic. Why we study statistic? Because the study of statistic require minimum effort and minimum resources as compared to the whole population under study, and statistic will provide an estimation, not the exact or the true value of that particular population, but the estimated of characteristics of that population under study. Depending upon the size of the universe, depending upon the resources available. If the size of the universe is large, the sample size will be large. If the size of the universe is small, the sample size will be taken as small by the researcher. If large number of resources are available to the researcher, in that particular case, the sample size will be large depending upon the availability of the resources. If the universe or the population is heterogeneous, in that particular case again, large sample size is chosen, and in case of homogeneous universe, the small sample size is also representative of the population. If we are going to conduct continuous but intensive kind of an study, in that particular case, small sample size is taken, but in case of larger and extensive study, the large sample size is to be studied for that particular population. Depending upon the type of the sampling technique used, again the sample size is dependent upon that, and if the number of the respondent are less for that particular population, in that case also the larger sample size is to be taken. Simple random sampling technique is used when the population is not much and the population is homogeneous by nature. Stratified random sampling method is used when population is of large size and there is heterogeneous characteristics of that particular population. Systematic random sampling is used when the list of individual is already available to the researcher. He will select systematically the number of the sampling unit from that particular population. Cluster sampling and area sampling technique is used when the data or the population is scattered largely and the list of individual is unavailable and the characteristics of the population is unknown. In that particular case, cluster sampling is used. Multi-phase sampling is again used when the population is divided on the number of the bases or variation among the population is much. In that particular case, the researcher will choose multi-phase sampling technique. Judgmental sampling technique is depend upon the experience of the researcher. Public policy opinions are day-to-day business decisions are taken by choosing this particular judgmental sampling technique. Convenient sampling technique is again dependent upon the choice of the researcher to whom he want to interview or what kind of sampling unit he want to introduce into the sample study. Purposive sampling is when there is an arbitrary method or predetermined criteria that is fixed by the researcher, and based on that particular criteria, he will choose the sample size. Snowball sampling is used when the population is very small and the researcher will identify the initial subject, and from that particular initial subject, he will going to choose different samples for that particular population. Quota sampling is used when, what's the difference between quota and stratified sampling is? Quotas are based on some specified criteria and quota is again not a, it's a non-probability way of selecting the sample from that particular population.
Hello.
Yes, sir.
Good morning, ma'am. I'm from SRM University.
Yes, sir.
I have a doubt on your random table. How you use that random table and what this column and row signifies, and how can we come out that unit of the size or the sample size?
Sir, can you please repeat your question? How we use random table and?
On the random table slide, is it random table? You use one random table slide, and how we use that table to come out the sample size? Yes, this table. Yes.
Sir,
what this column and row signifies, and how can we identify or determine the sample size out of this random table?
Sir, while using this particular random table, for example, if you have a population size of 900,
Yes,
population size of 900 means you need to label this random table started from 001 up to 900. First step is to list the table or label the table according to the size of the population. If the size of the population is of 2 digits, in that particular case, the list, you will enlist the table from 01 up to 90. If the size of the population is of 4 unit, then the labeling is started from 0001 up to 9000 depending upon the size of the population. Next step is, for example, if you want to select sample size of 30 out of 900 population. Sample size of 30 out of 900 population means you will select any arbitrary, any column and any row from this particular table. For example, if I am going to select 15 to 19th column, 15th to 19th column and row number 5. This is 15 to 19th column and row 5. The first 3 digits, my population is of 3 digit. I have to take first 3 digit, that is 922. But 922 is larger than the size of my population, that is 900. So I will exclude this particular digit, and the next is 357 830 859 411. Likewise, I need to select 30 different units from this particular table, and those unit will become the sample size of my population. This is how we use random table. Arbitrary, you can select any column, any row, and you move to the downward direction of the table, and you will select the sample size from that particular table. Am I clear, sir?
Good morning, madam.
It's not required to move downward only. You can also move vertically or horizontally, not diagonally. Gandhi Engineering College, please ask your question, sir.
Hello. Okay. On the basis of their output, what are the different types of samplings?
Your question is?
What are the different types of samplings?
So the sampling is divided into two different parts, that is probability sampling and non-probability sampling. Under probability sampling, there is simple random, systematic, specified, cluster or area sampling. And in non-probability sampling, there is convenience, judgment, quota and any participant from CSC or EC?
Good morning, madam.
Yes, sir.
I am Mohan Kumar Chavan, Government Engineering College, Hassan. Madam, shall we employ two different sampling techniques for particular study?
Sir, the choice of sampling technique is totally dependent upon the characteristics of the population under study. For example, if you are going to use stratified sampling and quota sampling for same kind of an study, there are some specified characteristics to be identified for that particular population. All kind of sampling technique have some specified criteria on the basis of which they are used for that particular population. We cannot use two different sampling technique for the same study. The result may be misleading.
Okay.
So thank you very much.